Throughout our class, we focused on pseudoscience in relation to archaeology, and there's been a distinct divide between pseudoscience and science. But how clear is that divide really? But it's obvious, isn't it? Pseudoscience is a false claim using false evidence. But what happens when valid evidence makes a false claim? Before we delve into the complexities of pseudoscience and science and the inaccuracies within science, let's first look at a pure pseudoscientific. The first example of pseudo-archaeology that we are going to be looking at is the Fiji mermaid, which, similar to other examples in our class, is going to involve a hoax.
Ariel, listen to me. The human world, it's a mix. Life under the sea is...
Now that is just disgusting. Was the Fiji mermaid a real mermaid? Of course it's not. It was originally from a Japanese fisherman who most likely had an affinity for practical jokes. Eventually, it was sold to Captain Edis, an American sailor, and he put it in his will to his son, who eventually sold it to P.T. Barnum, who owned a profitable American museum in New York and whose name had been associated with other hoaxes. P.T. Barnum was the last chance for the mermaid to blow up, as previously the sailor and his son had tried to make it a big hit. After passing from museum to museum, it ended up disappearing. But what was this so-called mermaid fossil made out of? I won't get too into it because it tends to get a little bit gross, but they used orangutan parts, baboon parts, and the entire body of a salmon and stitched that together to look like something somewhat resembling a mermaid. But you can never fall for something like that, right? The center of Volos was a centaur exhibit in the University of Tennessee created by a professor to test students' skepticism and critical thinking. Like other works under archaeological fiction, the display uses conventions of scholarship to present a work of fiction as authentic, and the only thing that points towards the viewer to be skeptic is the plaque that says the words, "Do you believe in centaurs?" When professor of art from the University of Tennessee, Beovis Lyons, sorry if I butchered that name, asked his student if he believed in centaurs, he said that he wasn't sure and that it looked quite authentic, showing how he was easily swayed by something in an academic space. This exhibit shows how a healthy amount of skepticism is good in an academic setting, and that is why it is in the University of Tennessee. Skepticism for skepticism's sake can lead to spreading of conspiracy theories and hoaxes, but a healthy amount of skepticism is needed in an academic space. And as you will soon see, even scientists can fall victim to these hoaxes. The Piltdown Man is an important aspect of archaeological history and shows why science should many times be looked at on a spectrum, as it is one of the biggest hoaxes in the scientific community. The story begins in 1912 when fragments of a skull and jawbone were discovered in Piltdown, England. These remains were hailed as a missing link between apes and humans. They suggested a human-like brain case combined with an ape-like jaw structure, challenging existing theories of human evolution. Initially, the discovery garnered widespread acceptance. However, controversy soon followed as scientists debated the authenticity of the find. Two advancements in archaeological studies caused this hoax to be exposed. In 1949, advances in dating methods, particularly fluorine dating, cast doubt on the authenticity of the Piltdown remains. Further analysis revealed discrepancies in the composition of the fossils, suggesting tampering and forgery. Then, following that, in 1954, evidence of forgery came to light. The Piltdown remains were found to contain foreign elements and artificial staining. X-ray and chemical analysis confirmed the manipulation of fossils, leading to the conclusion that the Piltdown Man was a hoax. What I find interesting about this is I don't see it as a pure pseudo-scientific claim that they made, because they did support evolution but used false fossils to prove a certain theory of evolution, therefore making it pseudoscientific. So what I will be exploring in the latter half of the video is what happens when correct scientific data comes to an incorrect conclusion. But I thought the Piltdown Man was a good example of the opposite of that, when a correct conclusion, evolution, is concluded using false data, the Piltdown Man. There will be two studies we will be looking at, one by Yi-Maw Chang and one by Peter J. Wagner. So first we're going to be talking about a simplified version of Yi-Maw Chang's study, which uses a lot of complex math, so I'll be probably skipping over that, but the study will be sourced in my bibliography if you're interested on looking at it further. So when we find a bunch of fossils in a particular area, we want to know what types of creatures lived there and how many were around. So we use percentages to represent this. But here's the catch. Can those percentages be exactly right? That's where the study comes in. We're trying to figure out if any mistakes in the calculations and are there any better ways to do it. One scientist named A.L. Dryden Jr. started looking into this day. He found that sometimes the more common a fossil is, the more likely we are to make a mistake when estimating its percentage. It's like trying to count a huge flock of birds flying by. The more there are, the easier it is to lose track. We discovered that when we have a lot of fossils to study, we can't always count every single one. So we use a math estimate to estimate the percentages based on a smaller sample. But even then, we have to be careful because our estimates may not be spot on. Understanding these errors is crucial for paleontologists because it helps them interpret and not make any false claims in their writings. So, to sum it up, estimating fossil percentages is like solving a puzzle with missing pieces. We're going to get better at it, but there are still challenges to overcome. By being aware of these challenges, we can piece together the story of Earth's past. I really thought this study was important when looking at it because, as you can see, even scientific studies can have error. Although they are much more accurate than the pseudoscience claims that I've shown previously, you can now see how much estimation is actually involved in science. Now on to the next study by Peter J. Wagner, The Quality of the Fossil Record and Accuracy of Phylogenetic Inferences About Sampling and Diversity. So most likely I'm just going to be going over the conclusion and what the study found, but I would highly recommend looking over the study as it's very interesting. The study talks about how scientists use a family of trees to understand the history of different species. It states that sometimes these family of trees can be wrong because not all animals are found as fossils, so scientists might not have all the information. They do computer simulations to see how accurate that these families of trees are when they use incomplete information. And they found that when they have less and less sample size data and less data overall and try to fill it in using computer simulations, it is often wrong. This means scientists need to be careful when using this method in order to understand how animals evolved over time. The conclusion even uses the word skeptical of particular estimates of phylogeny and why we should be skeptical of them. Hope you guys enjoyed my video. This is the spectrum I was talking about. I drew it out. Hope you guys thought this topic was interesting. I know it's a little bit not complicated as it is
maybe all considered all over the place, but I hope you guys enjoyed.